So the recording's on so that I can share it with anybody who's not here from sections 401 and 402. But again, we're going to work on some more vector addition in the first part. If we have time, we'll take a look at 3 dimensions, although we tend not to have time usually for that. And then we'll work on assignment number 2. And as was with last time, if you guys can get it done now and upload it, it's to your benefit. And if you can work on assignment 1 and assignment 2, you're in good shape for test number 1. Okay, so let's take a look at an example. Or maybe we'll first go through the steps first. So what we're doing is we're going to always resolve our vectors into our x and y components. That's what I suggest. And you can actually put it in the Cartesian system, although I don't. And the reason why the Cartesian system is used is some people are more comfortable with it. And adding all the i's, for me, it's adding all the x components, or adding all the j's, or adding all the j components. And like I said, different people have a different method, but this is, I don't like to get into I and j. Okay? So let's now work on this example here. So you've got I'm going to first work with the first one. That's 250 newtons. You've got a slope of 3 by 4. So we're going to call this, I'm going to call this F1. That's what I would do. I would break it down. When you have a question like this, I would break it down. And let's first work on F1. And what are we trying to find? F1x, F1y. So first, I would like to determine what this angle is. So tangent of theta is equal to opposite over adjacent. So theta is equal to, let's go ahead and calculate that. $36.8698 degrees. Good. So now what we're going to do is we're going to get F1x and F1y. Right? How did I get this? Because I used the slope. The slope allowed me to determine what theta is. Is everybody clear on that? That if you're not given any other information, with the slope, rise, overrun, you can determine theta. So sine of theta is equal to F1y over 250. So F1y is equal to 250 sine of 36.8698, which is equal to 150. So we're going to save this somewhere here. Okay. Is it upward? Yes, so it's positive. Now F1x is equal to 250 cosine 36.8698. What does that give us? $200. So F1x is equal to 200 newtons. But it's in this direction, so I'm going to put a minus here. That's really, really important. Are you guys with me? Are you all with me?
There.
Yes, Professor.
Now what I like to do is I like to focus on the next vector. Break it down, focus on just one thing at a time. If you go back to the slide, you'll see, and I'll use a different color to help distinguish. You will see 400 newtons. And you see an angle of 30 degrees. We will call this F2. And this will be F2y. This will be F2x. And we can already look at this and say, well, F2x is in this direction, stays positive. F2y in this direction stays positive. So F2y is equal to 400 times sine 30 is equal to, and F2x is equal to 400 cosine 30 is equal to. Make sure that you are careful about how you use sine and cosine. That's another source of error for students if they use it incorrectly. So that'll give us 200 newtons. This gives us 346.41 newtons. So that's what I'm going to do. I'm going to store this somewhere. F2x is equal to 346.41 newtons. F2y is equal to 200 newtons. Are you with me? Or is anything unclear?
Yes, Professor, it's clear.
It's clear, sir.
Now, you have F3 is equal to 300 newtons. Is there a y component? No. This F3 is equal to F3x. So that is the last. F3x is equal to 300 newtons. F3y is equal to 0 newtons. Now, I'm going to give you guys a few minutes to work on this, to come up with the resultant. How do you do that? You add all x components, and then you add all y components. And whatever you get is the x and y component of the resultant r. Okay, then what you do is you use the x and y of r to get its magnitude and direction. So I'll let you guys do that now. You should be able to. Okay, so let's see. I'm gonna work on this. Hopefully I get it right, and hopefully you guys also got it right. So let's go ahead and solve this. So adding the x components, we have 346.41 minus 200 plus 300. So we're going to call it Rx is equal to, let's see what we get. 346 plus 300 minus 200, 446. 446 newtons, and our y is going to be, well, it's 0, 200, so it's 350 newtons. Okay, so let's go ahead and try it. 350, 446. So what is R? R squared is equal to 350 squared plus 446 squared. R is going to be equal to 225. So I get newtons. So it's about 567 newtons. I round to the decimal place, 0 decimal places. And so theta is going to be equal to inverse tan of 350 over 446. 38.1 degrees. Okay, so that's basically the answer. Did you guys get the same answer or did I lose you somewhere?
I got 38.4.
That's fine. Don't worry about that. I would mark that as correct. The reason why I'm asking you this is that let's say you are not getting this, and if you write the test and you do not succeed, at that stage, there's almost nothing I can do to help you. This is the time to make sure that you are getting this. And that's why we have the assignments. It's to help you as well. Okay, let's see another question. So let's take a look at this question now. Are you in a good position to so as previously mentioned, we're going to start and I'm going to save what I have. So I know F1y is already 300 newtons and F1x is 0 newtons. So that's the start. Okay, so that's the first one. Let's work on F2. So working on F2, let's sketch that. Given the slope, no, actually I'm working on F3. Sorry about that. I've already started, so I'm going to leave it at F3. So 600 newtons, and we've got a slope of 4/3. So this angle theta is going to be equal to this is 4, this is 3. So theta will be equal to 53.13 degrees. So F3y, F3x. F3y is equal to 600 times sine 53.13 degrees, which is equal to 480. And F3x is equal to 600 times cosine 53.13 degrees. $360 newtons. So we'll save that somewhere. And because x is in this direction, y is in this direction, we leave it as positive.
Professor, we can calculate the theta by using sine because they give 5 2, right?
Yeah, you can use any one you want.
Okay,
This is what I'm comfortable with. There's multiple methods. As long as you come to the right answer, I am very happy with whatever you give me, as long as you come to the right answer.
Okay, Professor, thank you.
Okay, so let's take a look at F2. So it's F2. The angle is given 45 degrees. 450 newtons is equal to F2, F2x, F2y. So F2y is equal to 450 times sine 45 degrees is equal to, and F2x is equal to 450 cosine 45 degrees. That's 318.198 newtons. And it's going to be pretty much the same because cosine 45 and sine 45 is exactly the same. So it's the same answer. But F2x is in a negative direction, so we're going to have to make note of that. Minus 318.198 newtons. All right, so I'll give you guys a few minutes to try to finish that. Okay, let's solve it. So adding the x components, I'll say our x is equal to 0 plus 360 minus 318.198. It's 318.198. So that is 41.802. Ry is equal to 300 plus 480 plus 318.198. It's 1098.198. So the magnitude R is going to be equal to 41.802 squared plus 1098.198 squared. So R is equal to 1098.99 newtons. And Ry equal to 1098.198 newtons. And Rx is equal to 41.802. Therefore, this angle theta is equal to inverse tan of 41.802 divided by 1098.198. It's 2.1 degrees. Unless I've got this wrong. Or the book has it wrong. One of us has it wrong. I think they've done the tan wrongly.
Sir, would you have to divide the 1000?
Or have I done this wrong? So I've got X and Y mixed up.
Sir, would you have to divide 1098 over
41.02. It should be the opposite.
yeah.
So then this would be 87 degrees. So this should actually be 1098.198 over 41 point. So this will be about 87 degrees. So this should actually be 87 degrees. The book is right. It's not to scale, but this should be 87, about 87 degrees. Okay. Or 89 degrees or 88 degrees. Okay. So it looks like you guys did that right. Thank you for pointing out the error. Let's do another one before we work on your assignment. I think we have time for another one. Although the assignment will take some time. We might need some time today and some time in your next class. So let's say we've got 5 questions. Let's try to finish at least 3 today. That way, you'll be in good shape for next week. Because we also have to do a quick review for your test number 1. Remember, test number 1 is not next week, it's going to be in 2 weeks. And I wanted to point out for the people in 701, test number 1 will be in class on campus on Friday in 2 weeks. For people who are not in class for a 142, there will be a few time slots for you to write the test on camera when convenient to you on Monday, the 9th of June. Okay? And I will be in touch with you guys about that. Let's say you can't make either of those time slots, just tell me. We'll work something out. Again, I do want to watch you. I want to make sure you're writing the test alone. Make sure you bring your conversions and your formula sheets as well. Okay? All right. Wondering which question should we do now? How about we work on this question? This time I'm going to let you guys get started, and I want you guys to figure out F1 X and F1 Y. And I'll give you 5 minutes to do that, and then we can go from there. And then I'll work on F2 X, F2 Y, F3 X, F3 Y. I'll let you guys figure that out for me.
Thank you, Sudan. I really appreciate it. No, I mean, I have no intention of.
All right, let me start working on this with you guys. Let me know if I got the right answer. So F1y, so F1 is equal to 300 newtons. It's at an angle. So what is this angle equal to? So it's equal to, theta is equal to opposite over adjacent. It's not a very good picture. I know it's not to scale. So opposite over adjacent.
Sir, we can't see the full.
See it? Let me change the camera angle. Okay, so you should be able to see it now.
Thank you, sir.
12 over 5. Hopefully I got it right this time. You divided by 5. So that's what? 67.38 degrees. So F1y is equal to 300 times sine 67.38 degrees. What is that equal to? (276.92 newtons. And F1x is equal to cosine 67.38 degrees multiplied by 300. That is 115.385 newtons. So if you got that, you were on the right track. At least I think you were. And then you've got F2, it's 500 newtons. You've got the angle. F2, F2y, F2x. So F2y is equal to 500 times sine 30 degrees is equal to, and F2x is equal to 500 cosine 30 degrees. And this is what this is equal to. That is for F2. For F3, let's go 600 newtons. F3y, F3x. This is 45 degrees. So F3y is equal to 600 sine 45 degrees. And that's going to be the same as F3x, except whatever you get here is going to be minus. Why? Because it's in the downward direction. It's minus 424.26, and this is 424.26. And then you simply add them up, and you get your answer. I think the slides have the answers for you. Okay, so I guess no questions then. Just wanted to go through a couple of minor things. Well, not really minor, but so you can actually have situations where you have forces in 3 dimensions on different planes. And that's where having a third component comes in. Okay? We don't do that at this stage. We don't work on that at this stage. But you would have FZ. And that's where the Cartesian system might be a better way to make your calculation. But it gets a little bit complicated, which is beyond the scope right now. Okay. All right. What are we going to do next? We're going to work on assignment number 2. So we're going to work on assignment number 2 after a short break. But before we go on break, this is what we'll be doing next week. We'll be working on moments. We're going to be working on the moments of forces. Okay? So it's important for you to understand vectors now, because it becomes easier when you use vectors in moments. All right. So take a short break, 5 minutes or so, and then when we come back, we will work on your assignment. Okay, so let's work on your assignment number 2. Well, first let's take a look at it. So here's assignment number 2. What do you need to do? Just find the resultant of the two vectors given. Make sure you calculate the direction, and you also make a sketch. It's easier that way. That's number 1. Number 2, draw out the plane at this angle, calculate the horizontal and vertical components. Number 3, calculate the resultant of these two forces. You've got 2 vectors here. If you complete it to this stage, you're on track. Next week we can finish 4, which is actually very similar to what we just did. I don't really care if you indicate which quadrant it's in, as long as you show the direction of the resultant. Okay. And same here, you've got 3 forces. Find out the resultant. Okay, so this is meant to be an in-class assignment. So this is the time for you to work on this. And of course, it's your choice if you want to stick around and work on it or if you don't. But then if you don't, and you come back to me with questions, I'm going to be like, well, why didn't you stick around? Yes, they're all in 2 dimensions, Mackenzie. There's no 3-dimensional work here. We haven't done enough. We don't have enough time to work on it, and at this stage, it's not really a part of your learning outcomes. It's only 2 dimensions. 2. And is everybody clear on the fact that next week we will go back to the regular routine? In week 5, we have 3 more weeks after this week, 5, 6, and 7. And also remember, I am not going to be here after week 7. You will have a different professor. So try to get as many marks as you can with me. You never know how hard or easy the new professor will be, but I've only heard good things about him.
Sir, question.
Yes, go ahead.
The decimal places, is it always like 1 decimal place for all the answers?
I look for 2. It's up to you. I'm not too picky, but I look for 2 decimal places. And I'd like to keep it at 4 decimal places during the calculations because it minimizes the rounding error. But again, I'm not too picky.
Okay, sir, thank you.
If you come across a picky person, then you have to be more careful. And just this is for 701. Is everybody clear? We're meeting again in person next Friday.
Yes, sir.
Good. So I'm going to stop the recording here because I don't see or hear any questions, and I'll let you guys work.